Welcome to this YouTube channel. In this video, we'll be seeing a brief introduction about neural networks. Neural networks are currently used to recognize patterns like recognizing handwritten digits or like recognizing images or voice-based certain things, stuff. And so now neural networks has been used by many MNCs for this regard. So we'll be seeing in later videos how we can use neural networks to recognize handwritten digits. But for now, we'll be starting with the basics. So to begin with, I'll be introducing you to perceptrons. So perceptrons are nothing but this is an artificial neuron. So human neurons, they form a network, and input from a neuron just propagates throughout the network, and finally we get an output, which is an action that the brain signals our body parts to just perform. So in the same way, there are multiple perceptrons that form as a network, and they function and they process the input given to the input layer, and they just give a output. So now let me just draw a single perceptron. So this is a single perceptron. So let me just write that perceptron. And now if you see, you can give n number of binary inputs to this perceptron. So I have just taken 3 inputs, but you can give any number. And the output will be a single output, which is also a binary one. So when I mean output, so when I mean binary, this is just 0 or 1. So the 0 or 1, it is just bits, and it is actually used in normal circuits, like where 1 just means that the circuit is on, that is current flows through it, and 0 just represents that situation when the circuit is off. The same thing in perceptrons. In perceptrons, 1 represents the condition where the neuron is active or it is said to be fired. When I say a neuron is active or fired, it just means that the output received from this perceptron can be used as an input to another neuron. If the value of the output is 0, the neuron is inactive or it doesn't get fired, not fired. It just means that if the value of the output is 0, there is no contribution made by this perceptron to the output, because the circuit, you can just relate it to the condition where the circuit is off, like there is no current flows through it. This case just means that the perceptron is just idle, it doesn't contribute or make sense. Okay, so fine, let me now just introduce you to a new term called weight. Now what is this weight? Now this weight is a numerical value that just represents how much the inputs contribute to the output. Like each input, like if there is n number of inputs, each input have a related weight. So for input 1, the weight would be W1. So for input 2, the weight would be W2. And so for input 3, the weight would be W3, and so on. For input n, the weight would be Wn. So for each input, there will be related weight. So this weight just indicates the proportion of input that just contributes to the output. Higher the value of the weight of input, higher the contribution of input to the output. So let me just now introduce to a new term called weighted sum, which is nothing but the sum of all the product of input and weight pairs. So let me just write it down. Input 1 into weight 1 plus input 2 into weight 2, and so on till input n into weight n. So this is the weighted sum. So now there's also another new term called threshold. So this threshold is also just a mere numerical value, and we can use this weights and this threshold, and we can adjust them to get a desired behavior of the model. So we can either decrease the weight or decrease the weight, increase or decrease the weight, make changes to the threshold or make changes to both of them, so on. So we'll be initially assigning a random values to them, and we'll be fine tuning it so that the model performs to our convenience. So now you'd be getting a question like, when is the output 1 and when is the output 0? Now let me tell you when the output is 1 and when the output is 0. That is when the neuron is active and when it is inactive. So the condition when the neuron is, I just think I made a wrong. Sorry. Okay. So okay, fine. Now if you consider here, there is this weighted sum and there is this threshold. So now you may have a question like, when is the neuron active and when is the neuron inactive? So like, when is the output 1 and when it is 0? So these conditions are determined by this value threshold. So when the weighted sum neuron active, when the weighted sum is like it is greater than or equal to threshold, like it is at least the value of threshold, we can say the neuron is active. So, and for neuron inactive condition, I would say when the weighted sum is less than the threshold, I can say the neuron is inactive. The threshold is the value that determines if a neuron is fired or not. So if I just increase the value of threshold, then it makes it difficult for the neuron to get fired. So by increasing the value of threshold, I'm just suppressing the event of firing of the neuron. So let me just give an example. Like initially, if the value of threshold is 10 and the value of weighted sum is 20, this is the weighted sum. Initially 20 is greater than 10, so the neuron will get fired. If I just gradually increase the value of threshold, like from 12, 15, 19 and 20 till 20, the neuron will get fired. But if I just increase it beyond 20, like 21, 30, just if I go on, the neuron will not get fired. So like now you just understand the thing, right? So increasing or decreasing the threshold, and also you can even increase or decrease the weight. Like if the values of the threshold is, if I made the value as 100 and still your weighted sum is 20, you can just increase the weights. Now increasing the weight can actually increase the value of weighted sum, as if you see here, the weighted sum is dependent on the weight of each input. So if I just increase the weight, you can also uh, change the behavior of the neural network. So fine. So now let me just give you a algebraic expression of output. So I can write output equal to 0 when the summation of all the uh, inputs from 1 to n in this weight is less than the threshold, and it is 1 in the summation is at least equal to at least the value of threshold, that is greater than or equal to threshold. Simple as it is. Let me just give you an example how changing the new threshold and the weight can alter your behavior of the networks. So now let me just take the artificial neuron, that is the perceptron. Okay, now I'll be giving 3 inputs, I1, I2, I3, and an output. These input and output, they just represent a scenario or an event. So let me just give what's the event. So I1, the input 1 would be representing my friend coming to class. Input 2 would be the event. It rains. It is not raining. It is not raining. Input 3 would be my bicycle is in good condition. good condition. So now if you see, the output would be representing the event me attending the class, attending or going to class. Okay, fine. So now each of these inputs would have a respective weights. Now I can give any random value to them. Now I'll be just for the moment I'll be assigning 3 to weight 1, 2 to weight 2, and 2 to weight 3. Okay, fine. So now I'm seeing threshold, so I need to assign a value to the threshold. So it can be any random value. I'll be assigning it value 7. Okay, fine. So this, as I said, the value of inputs are binary. Input 1 can be 0 or 1. Input 2 can be 0 or 1. Input 3 can be 0 or 1. So the 0 represents the negation of the statement. Like 0 just represents that my friend is not coming to class. 1 just represents my friend is coming to class. The same applies for all the inputs. 0 just represents that it is raining, and 1 represents it is not raining. The same for input 3. 0 is my bicycle is damaged. 1 is my bicycle is in good condition. So fine. So let me just take it to case 1. This is the first case. This is the first case. Case 1. So here the scenario is I'd be assigning all the inputs a value 1. So what this represents is the scenario of my friend coming to class and it is not raining and my bicycle is in good condition. So let me just calculate the weighted sum for this case. So weighted sum would be, weighted sum is, as I said, input 1 weight 1, input 2 weight 2, and input 3 weight 3, which would give us some total of 3 plus 2 plus 2, which is like, let me just write down, 3 plus 1 into 2 plus 1 into 2 is equal to 7. So I have taken the threshold value of 7, and if you see here, weighted sum is greater than or equal to threshold, like it is 7 and threshold is also 7, so it just satisfies this condition. So the neuron get fired, that is the output is 1. When I mean the output is 1, what I mean here is I'm attending the class. The event is true, like I'm attending the class. So when I just give a summary of this case, it just means that my model just my neuron just says that if my friend is coming to class and if it is not raining, and also if my bicycle is in good condition, I'm just attending the class. So if you see here, my model is actually like model, or I would say the neuron. So my neuron is actually dependent on all the external factors, like my friend should come to class and the weather should be fine and my bicycle should be in good condition. So I just depend on all these characters, all these parameters. So let's see what just happens if any of them is just false. So I'll just write it as case 2, and input 1 would be 1 and input 2 would be 0. I will make this input to a 0. You can also make input 1 0 or in 3 0. Okay, just make any one of them a 0. So now if I calculate the weighted sum, as the input 2 is 0, the I2 into W2 becomes 0. So the weighted sum will be 5. Now if you see, the threshold is 7 and my weighted sum is 5. So weighted sum is pretty much less than the value of threshold. So in this case, the neuron is inactive. Neuron is inactive since sum is less than threshold. So now this becomes a problem. As I said, I'm just depending on all the external parameters. So in order to make my neuron adjust to the situation, what I can make is there is, as I said earlier, in order to alter the behavior of a neuron or a network, you can change either the weight or threshold. So now let me just change the threshold first, and then I will show how changing the weight will test the neuron. So now let me just change the threshold. So increasing the threshold doesn't make any sense because the weight 5 would remain same and the neuron would still be inactive. So in order to change it, I need to decrease my value of threshold. So I'll give a new value of 5 to the threshold. So threshold will hold the value 5. So now, if you see here, the weighted sum in the case 2 is 5 and the value of threshold is also 5, which is pretty much equal. So by the condition I have mentioned above, the neuron is active as the weighted sum is equal to the threshold. So here, the neuron is active. So now here, now the now my neuron just behaves differently from the previous case. Here my neuron doesn't give a shit about if it is if it rains or not. It gives preference to my friend coming to class, and either of these two conditions should be true. Either input 2 should be true or input 3 should be true. Like either it shouldn't be raining or either my bicycle is in good condition. But my first condition should always be true for this threshold value, because it has a higher preference of weight 3. If I just make this 0, the weighted sum would be something around 4, and which is pretty much less than the threshold. So I just made it a bit better than the previous case, where it was actually dependent on all the three conditions. So here, if you see, it's little bit better than the previous case, where my neuron actually depends on all these three conditions, all these three inputs. But now, if you see, it can just tolerate raining, or I can tolerate the situation where my bicycle is not in good condition. So my neuron has adapted to the situation a little bit. Actually, here I have made change to the threshold value. I can also make change to the weight and make make the model behave differently, like the neuron behave differently. So okay, fine. So just let me just keep this aside, and I'd be taking the threshold value at the same as the previous case, as the case 1 where threshold was 7. But I'll keep the inputs as in case 2, where input 1 is 1 and input 2 is 0 and input 3 is 1. So here the weighted sum was 5. So now what do I do? I can actually, here I was equally dependent on both the input 2 and 3, because I gave a value 2 for both the weights. So now I can actually make changes to the weight. So now here, if you see, I have given value weight 2 to the weight 2 and 2 to the weight 3. So now as I have made the input to 0, now I can increase the value of weight 3 or weight 1. So I can make the output more dependent on either of these inputs, input 1 or 2. So I can make it 5, or I can make it 3 plus, I can make it 4. So you can just make W1 5 or make it 4, or you can increase both of them. So there's no restriction on how you can change weights and threshold. So if I just come back here, and if I change the weight of W1 just 5, the sum would be now 7, because input 1 is 1 and weight of the input is 5 plus the input 2 is 0, and the weight into input 3 would be 2, which would be 7. Now the weighted sum becomes 7, which is pretty much equal to the threshold. So now the neuron is fired, the neuron is active. So you saw this both cases where I'm changing the threshold, or I can change the weight. So by doing either of them, I'm making the neurons getting fired. So this is how neural networks actually behave like we can make changes to the threshold, or we can make changes to the input, so that the neuron, the behavior of the neuron is actually altered. So that's fine, I guess. So now let me just introduce a new term, that is bias. So bias is nothing but the negative of the threshold. So in the upcoming topics and upcoming videos, we won't be using threshold. We'll be just using the term bias. Now we will be modifying our algebraic expression for output. So where did we write that? We will be just modifying this. So okay. So here, so the output is equal to, initially it was like 0 when the sum is less than threshold. Similarly, 1 when the sum is greater than or equal to threshold. So now what I'd be doing is I'd be bringing this threshold to this left side. So now let me rewrite this output. So it would be minus threshold less than 0 for 1, minus threshold greater than or equal to 0. So fine. So now I'll be just replacing this minus threshold with my new term bias. So the output is 0 when the sum of this, so this should be replaced with bias. So plus bias less than 0, and 1 when die plus bias is greater than or equal to 0. So that's fine. So now we'll be calling the minus threshold as bias, and we'll be using this for our further topics and further discussion. So that's it. Now this is the final algebraic expression of output. So thank you for staying in. I'll be discussing more about neural networks in the upcoming video. Thank you.